In this video, we're going to go over how to use the inverse trig formulas for differentiation. So here's the formulas. I'm going to give them to you, so you don't have to memorize. Them, but you do have to know how to use them. Just remember that just like regular trig functions, they can only have a single variable in them. So if I were to ask you to take the derivative of the sine of x, you would just get the cosine of x. If this is anything other than just a single variable, we must use the chain rule. And so these formulas actually take that into consideration. So if this is just x, then we would put a 1 up here because that would be the derivative of x. And then we would plug that number in right here, which would be x. So if it's x squared here, this would be 2x because that's the derivative of whatever that expression is inside that inverse sign. And then whatever this is goes right here, and that's it. So the hard part is just knowing the formulas, but again, I'm going to give them to you. So we're mostly doing them just so that you know they exist. And then just in case you forgot what they are, remember there's two ways to notate the inverse sign. So we could call them arc sign, or sometimes we'll see them written as inverse sign. And all that means, remember the inverse functions, if this is my function y, I can turn this back into a regular sign if I flip-flop my domain and my range. So just like before, whatever this number is would go here, and then whatever the y is would go here, and then just remember that we switch the x and the y. So this is how we could kind of find that regular version. And so basically, since our domains and our ranges are switched, normally this is our angle. And it's asking what is opposite over hypotenuse of that angle? What is that trig function? In the inverse sign, my angle is now over here, because remember those domains are now my ranges. So it's basically asking, I don't know, let's say 1 over 2 is the sine of what angle? So if you were to actually solve these, you would look on the unit circle, figure out where which triangle would fit the opposite side of 1, the hypotenuse of 2, and then you could figure out that angle, and that angle would be your x. That's what an inverse trig function does. You don't need to know that, but just in case you were curious. So in our example here, again, all we're doing is following this formula. This says whatever's inside of the inverse trig function is our u. So in this case, this x squared is our u value. So to use this formula, we're going to take the derivative, put it on the top. So this just says take the derivative of this function here. So we'll have negative, whatever that u value is, u prime, so we'll do 2x all over the square root of 1 minus whatever that u value is squared. And since that u value is x squared, I'm then going to square it. And this is it. Okay? And in college, you'll probably work these out. They're really not that hard to work out. They just take a long time because they use values on that unit circle, those special right triangles. And then they involve Pythagorean theorem. And so that's why there's a square root in them and all that good stuff. Okay, our last example with this. Again, this is just a different way to say the inverse sign. This is my u value because that's what's inside of my inverse trig function. So I'm going to put its derivative in the numerator. So the derivative of f is going to be the derivative of this u function. So 10x would go in the numerator. In the denominator, all I have to do is plug that u value in here. So it's going to be the square root of 1 minus 5x squared, and then I have to square that. So the biggest mistake people make is they forget to put that in parentheses. But this is it. We don't need to simplify. We're just kind of plugging and chugging. I just want to make sure that you know these formulas exist and how to use them. And then in college, I'm sure you'll have to memorize them.